everyone. Today I'm going to talk about power quality. Okay, what is power quality? Power quality is the electrical power supply that affect the performance of electrical equipments. Understanding power quality disturbance is essential for maintaining efficiency and reliability in electrical system. So this presentation will explore types of disturbance and their impacts. Okay, power quality disturbance can be classified into several types, including voltage types, voltage swells, transient, and harmonics. So each type can significantly impact the performance of electrical devices and systems, leading to potential downtime and damage. So what is voltage sags? Voltage sags are the short duration drops in voltage, while voltage swells are temporary increases. Both can cause equipment to malfunction or shut down. Understanding their causes such as motor startup or fault is crucial for effective mitigation. So let's talk about transient. Transients are brief, high-frequency disturbance that can occur due to lightning strikes, switching operations, or equipment failures. These sudden fluctuations can lead to equipment failure or data loss if not properly managed. Awareness of their nature is for protection strategies. Furthermore, I would like to explain a lot about effects of harmonics. What is harmonics? Harmonics are voltage or current waveforms that deviate from their fundamental frequency, often caused by nonlinear loads. They can lead to overheating, increased losses, and reduced equipment lifespan. Identifying and mitigation harmonic is essential for maintaining the power quality. So in this power quality assignment, students are required to find out a case study that happened in Malaysia. So I would like to explain a case study which is harmonic distortion in a Malaysian semiconductor manufacturing plant. So the Malaysian semiconductor manufacturing plant relies heavily on precision equipment, including variable frequency drives, which is VFDs, programmable logic controllers (PLCs), and advanced robotics. These systems are powered by a three-phase power supply. Over time, plants begin to experience mysterious problems such as frequent devices, overheating of transformers, and increased costs. Okay, let's talk about the problems that were identified. So, the first problem is nonlinear loads. The widespread use of VFDs in the manufacturing process introduced significant harmonic currents into the system. Furthermore, the measurement data, total harmonic distortion (THD) voltage exceeded 8% above the IEEE 519 standard limits of 5% of industrial systems. So the current THD was measured as high as 20% on certain phases. So the equipment failure points are overheating in transformer leading to insulation damage, malfunctioning of PLCs due to signal interference, and premature failure of capacitor bank used in power factor correction. Moreover, I would like to explain about the root cause analysis. First of all is VFD and inverters. These devices have created great harmonic distortion in the 5th, 7th and 11th harmonics. Second one is price of resonance. Harmonics interacts with plant and plant distribution systems causing resonance, improving the current distortion. The last one should be the existing filters were inadequate or wrong and the dominant harmonic frequency could not be removed. The solution that were proposed for this issue is active harmonic filters. Action is install active harmonic filters at critical points, particularly on VFD feeder lines. The impact were reduce voltage THD to below 4% and current THD to below 8%, compiling with IEEE 519 standards. The second one should be system redesign. The transformer upgrades. Replace standard transformer with K-rated transformers capable of handling harmonic loads. The last one should be the resonance mitigation. Added reactors in capacitor bank detune the system and prevent resonance with the dominant frequencies.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nazira Batizandi and today I would like to present about voltage imbalance and flicker. Voltage imbalance refers to a condition where the three phase voltages differ significantly in magnitude or phase angle. It is quantified using the voltage unbalance factor (VUF) and typically occurs when there is uneven loading or disruption in the power system. Voltage flicker refers to short-term voltage fluctuations that cause visible flickering of lights or instability in sensitive equipment. It is caused by sudden, large and repetitive changes in power demand. So next, main causes in Malaysia's power grid is separate into which is voltage imbalance and voltage flicker. For voltage imbalance, uneven single-phase load distribution. Second, power theft, that faulty components for line faults. Then, for flicker, first, heavy industrial loads. Second, large motor startups. Third, renewable energy variability. And four, weak grid connections. For residential environments, first, voltage imbalance leads to overheating in three-phase motors, causing insulation damage. It can also increase operational costs due to higher energy losses and frequent equipment breakdowns. Third, causes malfunctions in precision equipment and automation system. For flicker, it may disrupt production processes relying on stable lighting or electronic controls. It can be impact equipment that operates on sensitive voltage transition, leading to quality uh, issues products. Okay, next, industrial environments. Voltage imbalance may damage sensitive electronics like refrigerators or air conditioners. It can also cause appliances to overheat, reducing lifespan. Therefore, flickering lights can cause discomfort and visual irritation. It may affect the functionality of electronics, especially those requiring stable power supply. So, for power quality standards and regulations, so for global standards, first IEC International Electrotechnical Commission, IEC 61000 series. It covers electromagnetic compatibility and PQ, addressing harmonics, voltage sets, flicker, and interruptions. Second, IEEE, Institute of Electrical and Electronic Engineers. IEEE 519 until 2040 focuses on harmonic control in power system. IEE 1159 provides recommendations for monitoring and identifying PQ disturbances. Next, local standards. First, Suruhanjaya Tenaga Energy Commission of Malaysia, Greek code for Peninsula Malaysia and Sabah, Sarawak, regulates voltage levels, harmonics, frequency, and reliability of power systems. Second, distribution code governs PQ at the distribution level, ensuring stable supply for end users. Second, MSIEC standards, nation standards based on IEC, adoption of IEC standards for PQ tailored to nation's climate and infrastructure needs. So next, enforcement issues. Limited monitoring and enforcement of PQ standards, especially in the rural areas where grid reliability may be compromised. Inadequate penalties or consequences for non-compliance by industrial users contributing to harmonic distortion. So, for measuring power quality parameters, so first, next, instrumentation PQ measurements. There are seven instrumentation for PQ measurement. First, power analyzers. It is widely used in industrial facilities to monitor energy efficiency and PQ compliance and used by utilities like TMB to evaluate grid performance. Second, harmonic meters monitoring harmonic emissions in manufacturing plants and renewable energy systems. Third, oscilloscope used for diagnosing trace disturbances and waveform abnormalities in sensitive equipment. Fourth, flicker meters useful in areas with high variability in loads such as near steel or arc furnaces. 5. PQ monitoring systems installed by utilities to ensure compliance with PQ standards in distribution networks. 6. Digital multimeters with PQ capabilities used for routine maintenance checks and troubleshooting in residential and small commercial setups. 7. Voltage event recorders used in industrial facilities to identify the root cause of power interruptions. Lastly, for parameter critical PQ, first, voltage such as wells, critical for maintaining equipment functionality in industrial and residential environments. Second, total harmonic distortion (THD), a measure of voltage and current waveform distortion caused by nonlinear loads like inverters and variable speed drive. Third, voltage imbalance, important for three-phase system to ensure proper operation of motors and sensitive equipment. For flicker measures the event of voltage fluctuations on lighting and sensitive electronic devices. 5. Transients and fits, high-frequency disturbances caused by switching operations or lightning. 6. Power factor, a measure of how effectively electrical power is used. It means low power factor increases energy losses and grid inefficiency. 7. Frequency variations to ensure the stability of synchronous machines and grid-tied equipment. And lastly, voltage magnitude, ensuring supply voltage stays within regulatory limits to prevent over-voltage or under-voltage issues. That's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Adi Fasli bin Sulaiman. My date number B08211037. So the question 6 about monitoring and analyzing power quality data. Discuss tools and techniques used to monitor and analyze power quality data in Malaysia, and how can data-driven analysis predict and prevent power quality issues. First, tools and technique for monitoring power quality is in Malaysia. Monitoring and analyzing power quality data is essential for identifying disturbances and maintaining the reliability of the electrical grid. A range of tools and techniques is employed against challenge. Power quality analysis. These are specialist devices designed to measure key power quality parameters such as voltage, swells, harmonic, and frequency. Next, data loggers. Data loggers is about used to record power quality events over extended periods, offering insight into the frequency, duration, and severity of disturbances. By capturing transient events such as momentary voltage spikes, data loggers provide a historical perspective. Data-driven analysis for predicting and preventing power quality issues. Data-driven analysis is essential for managing and improving power quality in Malaysia electrical system by leveraging data. Utilities and industry can better predict. Last but not least, root cause analysis. Collected data from monitoring tools such as power quality analysis and smart meters help engineers perform root cause analysis. So the conclusion is data-driven approaches combine real-time monitoring, predictive analytics, and economic assessment to address power quality challenges in Malaysia. Question 7 about power quality mitigation technique. So the advantage is harmonic reduction. This system effectively minimizes harmonic distortion, improving the efficiency of the equipment and extending its lifespan. Next, such protectors shield electrical equipment from voltage spike. So the advantage is equipment protection. They safeguard sensitive equipment, ensuring operational continuity. The cost effectiveness, such protectors are generally affordable and easy to install. So the conclusion is, in Malaysia industry, effective power quality mitigation requires balancing cost, space, and specific challenges. So question 8 is about power quality and renewable energy system. So integrating solar and wind energy into Malaysia could boost sustainability but poses power quality challenges. Addressing this issue is vital as renewable production grows. So the impact is intermittent generation. Solar and wind energy fluctuate with weather, causing voltage and frequency instability. Harmonic distortion. Convert for renewables into disharmony, reducing equipment efficiency and increasing grid losses. Energy storage system. Description. Technologies such as batteries, flywheels, and supercapacitors store surplus energy during peak production for using during low generation rates. Harmonic filters. The description is this filter eliminate or reduce harmonic distortion introduced by renewable energy system. So the advantage is they ensure compliance with standards like IEEE 519 and improve the overall quality of electricity supply to consumers. So the conclusion is integrating solar and wind energy into Malaysia brings challenges like intermittency, harmonic, and voltage instability. Solutions such as storage system, flat device filter, and advanced forecasting can enhance power quality and support renewable goods. Ongoing innovation and investment are vital for grid stability and sustainability.
Hello, I will now talk about the industry, the power quality in the industry, especially in Malaysia's industry. Okay. First, we have requirements like compliance with power quality standards like IEEE 1159, 519, IEC 61000. We need a stable voltage and frequency levels. Like with, if they are stable, our equipment will not fail that easily. It's also important for the grip stability overall. And also we need also robust systems to handle sudden load changes. We will also talk about this later. In the industry, we have some challenges, like for example, voltage sags or voltage swells. Voltage sags happens if, for example, a motor will start up. By starting up, the motor needs a high starting current, which will cause into voltage sags. On the other hand, voltage swell can happen if we switch off this motor, like a huge load. These can cause like intermittent lockups, light flickers, or garbled data. Another challenge of power quality are harmonics, and harmonics are caused by non-linear components. These are also often found in the industry like frequency converter. Yes, these harmonics can heat up like a transformer or a motor, which will damage them and reduce their lifespan. So it's also very important for the industry. Um, yes, sensitive equipment can be damaged, and an inconsistent grid stability in a industrial zone also a challenge for the industry. To prevent them, we need mitigation methods. These are harmonic filters, uninterruptible power supply, short form UPS, and employee trainings. Harmonic filters are in a passive form or in an active form. The passive form is mostly just a low pass built with a resistor and a capacitor, and an active filter is low pass combined with a non-inverting amplifier. The UPS keeps the power grid stable, and they are not only machines working in the industry, they are also employees, and employee training is important to prevent failure. Now we're talking about the economics. Because of a water exec, the motors cannot start up, so they stand still, and the production will not start. So the production we get losses, and these will also have high costs. Harmonics can raise the energy consumption, which will also cause to energy costs, increased energy costs. The overheating will cause system wear, like as I mentioned, reducing lifespan or damaging the equipment, which has to be replaced, which will also cost. And if the companies doesn't stick to the standards, like IEEE, they have to pay penalty payment. To prevent all this or to save the cost in a long time span, we need risk management strategies, which is also preventing maintenance, like the equipment must be inspected more regularly. We need power conditions like the UPS, harmonic filters, and monitoring systems, and we can monitor the system with IoT. Yes, IoT is one of the future trends because IoT enables decentralized measurements, and there are two systems. Edge computing, there will be the proceeds data in the data will be proceeds in the device and will be sending to the cloud, and in the other system is cloud computing. There the device will just perform a measurement and send the raw data to the cloud where it will proceed. Cloud computing will be more suitable, I guess, for power quality applications because the devices are smaller and you need a lot of these devices. Yes, IoT and AI, artificial intelligence, can work together because IoT gathers a lot of data, and these data can feed the AI, and then the AI can perform and analyze these data to detect anomalies and predict faults. Other future trends are smart grid, and we need the smart grid to ensure efficient energy transmission, and we can also combine IoT and AI here for dynamic load control. And also battery storage technology is important because it is a mitigation for power interruptions, and it balances the fluctuations from the new renewable energy sources, especially during low production periods like for solar at the night or for wind when there is no wind. Yes. Thank you for your attention. And here are our sources. Goodbye.